You know, for decades, we've had this incredible baby picture of our universe. It's a snapshot from right after the Big Bang, called the cosmic microwave background. And honestly, it's one of the greatest achievements of modern science. But hidden in plain sight, right there in the image, is this deep, nagging mystery. A glitch. A glitch in the very fabric of the cosmos that our standard physics just can't seem to explain. Today, we're going to dive into that glitch and explore a truly radical new idea that might, just might, finally solve it.
So this beautiful map you're looking at, that's the afterglow. It shows these teeny tiny temperature differences in the universe when it was just an infant. And those little fluctuations, they eventually grew into all the galaxies and stars we see today. Missions like COBE, WMAP, and especially the Planck satellite have mapped this out with mind-blowing precision. And yeah, it confirms our standard model of cosmology almost perfectly, but it also shows these stubborn anomalies, things that, according to the model, just shouldn't be there.
And that leads to this just wild question. What if these aren't just random statistical flukes? What if they're actually clues, pointing to some fundamental truth we've completely missed about the very shape, the geometry of space itself? Okay, so to really get the solution, we've got to understand the problem first. There are three specific, very stubborn clues in our cosmic blueprint that have had scientists scratching their heads for more than 20 years. First up, there's missing power. When we look at the biggest possible patterns, the ones stretched across the entire sky, the temperature differences are, well, they're weirdly quiet. They're much weaker than our best models predict. It's like the universe is supposed to be playing this deep bass note, but it's just kind of muffled.
The second clue is this really bizarre lopsidedness. You can actually sort the patterns in the sky into even and odd mathematical groups. And for some reason, the odd-numbered patterns are way stronger than the even ones. I mean, the measured ratio is around 0.81 when it should be a perfect 1-to-1 balance. Something is clearly, physically breaking that symmetry.
And finally, there's the most infamous clue, the one with the killer nickname, the axis of evil. Turns out, the biggest, most powerful patterns in the sky aren't random at all. They're eerily lined up with each other, and the odds of that happening by chance, so low. It completely defies the basic idea that the universe should look pretty much the same in every direction.
So let's just lay it all out. We've got this power deficit at the largest scales. We have an asymmetry where odd patterns are beating the even ones, and we've got this strange, unexplained alignment of the biggest features in the sky. Look, any one of these, okay, maybe it's a fluke, but all three together? No way. That's not a coincidence. That's a clue that something fundamental is going on.
So how on earth do you explain all of this? Well, it might start with admitting that we've been thinking about the basic shape of our universe all wrong. A new theory suggests our universe has a twist.
Now, what does that even mean? Okay, stick with me here. Imagine taking a long three-dimensional strip of space. Now, you give one end a single half twist, and then you connect it back to the other end. What you've just made is a 3D version of a Möbius strip, a universe with a completely different kind of shape or topology.
Now, the crucial property of this shape, the whole shebang, is that it's non-orientable. That's just a fancy way of saying there's no consistent up or down or left or right. Think about it. If an ant walked one full lap along this cosmic strip, it would end up right back where it started, but upside down. And that single simple geometric feature, it changes everything.
And this is where it gets really cool, because this one simple geometric twist might just solve all three of our cosmic puzzles at once.
Remember that missing power at the largest scales? Well, in a finite Möbius-shaped universe, space itself acts like a giant resonating cavity. Think of it like a guitar string. You can't play a note with a wavelength that's longer than the string itself, right? Same idea. Our universe simply can't support waves that are too big to fit inside it. This naturally cuts off the power right where we see the deficit. The universe is just too small to play those super low notes.
Okay, what about the lopsided power? Well, that half twist in the geometry, the thing that makes it non-orientable, it fundamentally breaks the symmetry between even and odd wave patterns. It just naturally squashes the even-numbered modes. And that perfectly explains why we see the odd patterns being stronger. And the best part, you don't need any new exotic physics to explain this. It just falls right out of the geometry.
And the axis of evil? Suddenly, it's not evil at all. It's not some weird flaw. In a universe with a literal twist, there is a special direction, the axis of the twist itself.
So of course the biggest wave patterns, the ones that feel the overall shape of the universe the most, would line themselves up with this fundamental cosmic axis.
But here is where this theory goes from being just a neat idea to something truly jaw-dropping. It turns out that the exact alignment angle we see in the sky and the precise value of that even-odd power imbalance, they aren't two separate things. They are both determined by one single number, our specific location within this twisted universe.
Using what we see in the sky, that 10-degree alignment angle, to figure out where we are, the theory then makes this incredibly sharp prediction for what that parity ratio must be. It predicts a value of 0.814.
So, what did our best telescope, the Planck satellite, actually see? About 0.81. I mean, come on. The match is it's stunning. This isn't just fitting the data after the fact. It's a real prediction that connects two totally unrelated mysteries and just nails the number.
This is the beauty of it, all summed up in this one quote from the paper. One displacement, two observables. Our single position in the cosmos explains two of its biggest mysteries. You take one input from the sky, the alignment, and one feature of the geometry, and out pops the other observation, the parity ratio. It's beautiful.
Okay, an idea this huge, this radical, it needs extraordinary evidence. So is this for real? And more importantly for science, how could we ever actually know? How could we prove it right or prove it wrong?
Now you might be thinking, wait, haven't we looked for weird universe shapes before? Looking for repeating patterns in the sky, these mashed circles? And yeah, we have, and those searches found nothing. But here's the key, this theory isn't disproven by that. It argues the CMB isn't an image we're seeing through a hall of mirrors. No, it's the resonant pattern of the cosmic cavity itself. The shape doesn't create repeating images, it dictates which notes the universe is allowed to play in the first place.
And look, this isn't just some fun story. This is real, testable science. It makes specific predictions that could absolutely prove it wrong. If future observations find no power suppression, or if they find that even patterns are actually stronger than odd ones, or if the math connecting the alignment and the parity ratio breaks down with better data, then the theory's done. It's on the line, waiting for data from new missions like the Euclid telescope.
So, what's the big takeaway here? For 20 years, we've seen these glitches as flaws, as these annoying little deviations from our perfect, elegant model. But this new perspective, it reframes them completely. It suggests that these anomalies aren't noise. They're the most important signal of all, a signal that's been revealing the true, twisted, and honestly, magnificent shape of our cosmos all along. What we once called the axis of evil may in fact be the axis of light,